identify all the parts of this first graph. And this is the first one that we're going to do together that has a phase shift. Okay? So starting with number 5. What is the amplitude? 3. All right, we discovered earlier, because of the question that someone asked about WebAssign, that if there is no vertical translation, in WebAssign you need to put 0. So I'm going to put a 0 here. And now for me, you could put none, you could put NA, but for WebAssign they want a 0, so that's how I'll put it down here. Okay, what's the period? The period is just pi.
How did he know that?
Okay, because the formula for period is 2 pi over b. B is 2, so 2 pi over 2 is just pi. Okay, this is B right here. Look at your format that you just wrote down, right? So you're just matching up the letters A, B, C, D. I mean, you can use the H's and the K's and whatever you used last year, but making it A, B, C, D I think makes it a little bit easier. So formula for period is 2 pi over B. Always 2 pi. Why do we start with 2 pi at the top? That's the period for the parent function. So then we adjust according to the transformations. And since this is a 2 pi over 2 is pi, which means that in our graph here, we should get a peak and a valley within 1 pi as opposed to 2 pi. So it's shortening the amount of space that it takes to make a peak and a valley. All right, now, phase shift. Formula for phase shift is the opposite of whatever's in parentheses. So I know that my phase shift will move to the right, because that's a negative sign. And the formula is C over B. So pi over 3 divided by 2. It's pi over 6. That is correct. Now I'm going to show you. I want to show you something. I'll erase it in just a minute, but I want to show you something. One of the things that students get confused about with graphing is they think anytime they see parentheses, there's automatically a phase shift, and that's not true. In order for there to be a phase shift, I need to have an argument. This right here, that's your argument. So if you think about it in literal terms, unless you're a little bit demented, it takes 2 people to have an argument. So it takes 2 terms to have an argument. And they're going to be separated by a sign, plus or minus. And then what we want to do is we want to solve it, right? Find a solution for the argument. That's what this is. We're finding the solution for the argument. That is the phase shift. So if I think about this algebraically, okay, I'm going to change this to 2 theta minus 1/3. I'm going to leave the pi out because I know I can put it back in at the end. Equals 0. Think about it in terms of algebra. How would I solve for theta? So I would say 2 theta equals 1/3. Divide by 2. So theta equals 1/3 divided by 2. All right, well, how do you solve that problem? Keep, change, flip. Come up here and I say 1/3, that's keeping it. Divided by changes to multiplication. And I'm flipping 2 over 1 and making it 1 over 2. That would be pi over 6. Because what I'm solving for is theta. Theta is an angle. I just found the angle. I just do it without the pi if I'm solving it this way. But I want you to look at something. The formula for phase shift is the opposite of C over B. Isn't that what you get when you solve the argument? The opposite of C is positive 1/3 over B. That's what I get when I solve that very simple algebra problem. That's all I'm doing is changing this as a whole process to just be negative c over b. So the phase shift is a positive pi over 6. Any questions about how we're going to get that? Because that's the goal of today, is to work with these problems with the phase shift. Yes?
Should it always be positive? Or
It's not always going to be positive. It's always going to be the opposite of whatever's in the argument. Because when I solve for the angle and I move across the equal sign, what happens to the argument? It changes. If it was positive, it becomes negative. If it was negative, it becomes positive. Okay. So now we get to deal with some fractions. Yay. All right. So I'm going to start my graph. I know the midline is still at 0 because I do not have a vertical shift at all. So this stays y equals 0. My amplitude is 3. So my max is now y equals 3. And my min, y equals negative 3. Okay, so here's the new stuff. The phase shift is your starting point. You need to label that somewhere on your paper. Phase shift is your starting point. So when we were doing the parent functions, there was no phase shift. The starting point was at 0 pi. If I have a transformation horizontally, I'm basically just picking up the graph and starting it at a different point. And so on this one, it says my phase shift is pi over 6. So instead of starting that at 0 pi, that starting point is pi over 6. I'm shifting the graph away from 0 pi over to pi over 6. Okay. I've written 2 algorithms here that I think will be helpful as you're graphing things with phase shift. So the first one says phase shift plus the period equals the end point. The phase shift plus the period equals the end point. Phase shift plus period equals end point. So, phase shift of pi over 6, period of pi equals what? 7 pi over 6. Okay, pi over 6 is your phase shift, plus your period, which is pi. That's 1.
yeah. Oh.
1/6 plus 6 over 6, if I change it to a fraction, is 7 over 6. Yeah. That's exactly what it is. A phase shift is a horizontal shift on the angle axis. That's exactly right. All right, so I'm going to do the same thing I did yesterday. Half, half, and half. And here's where it gets a little tricky. So I wrote you another algorithm to follow. If you take the period and you divide it by 4, why 4? We have 4 quadrantals, so we're going to keep up that theme of 4. That will give us our interval width. Period divided by 4 is your interval width. And this is where if fractions are a challenge for you, you have a calculator. It's perfectly fine to use it, but let's use it the right way. Let's figure out how to do it. Yes, ma'am.
So whatever number you get for that is like you add to the
Constantly adding it to get your next interval mark. That is correct. So let's do it together. Now remember, we're not putting pi in the calculator, so we're just going to start out in our calculator with 1/6. We can add the pi ourselves. Okay. Period is pi. If I divide that by 4, what does that give me? 1/4. And then I can do this in decimals in the calculator and then just hit the math fraction key when I'm finished. So let's take 1/6. Your screen should now say 0.1666 repeating. All right, plus 0.25. Hit your math fraction key and tell me what you get. 5/12. So this becomes 5 pi over 12. Now leave that answer and do what? Add a 4th again, so plus 0.25. Math frac. So what should I get? 2/3 pi. 2 pi over 3. All right, do it again. What about now? 11 pi over 12. All right, and if we've done it right, then when we add 0.25 again, we should get 7 pi over 6. So try it again. Always take it all the way out to make sure you've done it properly. Did you get that? Awesome. That, guys, is the hardest thing that you do. What we just did to get those intervals is the hardest thing that we'll do. And remember, we've talked about this before. The fault of our graphing method is that if we're not careful with labeling, it makes it look like every graph is the same. It's really not. All right, so now we have to apply all of this stuff. We've got a cosine graph. There's no reflection. Cosine starts at the max. So we start at pi. And then what? Mid, min, mid, max. And then we sketch arrows on the end because we're going to continue in either of those directions, and we're done. Okay, we got to try several more before this will click. So don't get impatient with yourselves if you don't have it yet. Let's try the next one. All right, amplitude of the next one. 1. Any vertical translations? No. Okay, period. I heard it. I just want to make sure everybody gets it. Period is 2 pi. No. Are we okay with how we got the period? Does everybody understand why it stayed 2 pi? Because the coefficient beside the angle notation is 1, so it's really 2 pi over 1. Okay. Phase shift. There's a negative sign, so it means I move in the positive direction, in the right direction. So what's my phase shift? It's 2 pi. This one is a really interesting one, so in just a minute we're going to go to the calculator and look at it. All right, so I have everything I need to graph. No vertical translation, so we're at y equals 0 at the midline. Got an amplitude of 1, so y equals 1, y equals -1. Phase shift is my starting point, so this time what do? Start at 2 pi. Okay. Phase shift plus period equals endpoint. So it's 4 pi, so I end at 4 pi. Okay, so we divide that in half, half again, so I get quarters. So then I take the period of 2 pi and divide it into 4 equal parts. 2 divided by 4 is 1/2. Okay? So either do this in your calculator, turn 2 into something over 2, and just keep adding your fraction, do it in your calculator, however you want to get there. What is 2 plus 1/2? 2.5. But we need to write that as a fraction. 5 pi over 2. Well, I'm adding pi over 2, so my next one is 3 pi. Or 6 pi over 2. And yes, you do need to reduce. If I add that again, what do I get? 7 pi over 2. And just to be sure, if I add that again, I get 8 pi over 2, which is 4 pi. Everybody comfortable with what we just did? Okay. I don't really care. Do it in your head. Change this first one to something that's a common denominator. Put it in your calculator. However you need to do it. This is the challenge of graphing. So if you can get past the fractions, then you're good. All right, it's the sine graph. Where does the sine graph always start? At the midline. Then what? Max, mid, min, mid. Then Here's sketch a curve. Okay, so this one's kind of cool to look at. Does anybody have any idea really what we're looking at? And always comparing it against the parent function. Yes, Mary Grace, that's exactly right. Is the parent function shifted over 2 pi? Because think about it, the parent function started at 0 pi, correct? It had a period of 2 pi, and it had intervals of pi over 2, just like the unit circle, the quadrantals. So all we've done on this one is we've shifted it. So let's just go to the calculator, just so that I can show you what this looks like in the calculator. Like I said, the calculator. Okay, so go to y equals and put in your two functions. And then we need to decide, how do you want to do the window? Do you want to do the window so that it looks just like what we graphed, or do you want to do it from the parent function? It doesn't matter to me. You tell me how you want to do this. How about if we check what we did? So if we check what we did, let's go to the window. Now, why is my minimum 6.28? That's 2 pi. That was my minimum. That was my starting point. So that's how I listed my minimum. Okay. Why is my max 12.56? That's 4 pi. Why is my x scale 1.57? That's pi over 2. It's half pi. You can change the y max and the y min if you want to. You don't have to. All right, now for you guys, if you hit graph, you should see two lines. One, mine's been done already today, but one as it comes in, and the other one you may not even notice, and that's because this is the same graph. It's just been shifted over. It's a phase shift of 2. Everything else is exactly the same. Okay, that's why you only see one graph. All right, any questions on this one? Moving along. All right, so what do you notice about this graph? It is reflected. And so whatever you need to do just to make yourself aware when you go back and graph it that it does need to be reflected. All right, amplitude, 2. Do I have a vertical translation? No. Period.
6.5.
Yes. Do I need to do that? So the formula for period is 2 pi over b. 2 pi over b. B is what? 1/3. So 2 pi divided by 1/3 is 2 pi times 3. That's 6 pi. Okay? Now, what about the phase shift? Which direction does it move? It moves to the right. 3 pi. Very good. Okay, what's the formula for phase shift? Okay, so I'm going to take care of the negative by applying it to the phase shift answer. Okay. What is C? What is B? Keep it, change it, flip it. 3 pi. Keep it, change it, flip it. This is C. That's B. That's the formula for phase shift. Okay, so now I have everything I need to graph. What is the midline? Equals 0. What is the max? Equals 2. I have an amplitude to apply. And then my min is y equals -2. What is my starting point? 3 pi. What's my ending point? 9 pi. It's not 6 pi. And that's a mistake I see often, is that people just simply apply whatever the period is to the end, but it's period plus phase shift equals ending point. So this is 9 pi. Middle, middle, middle. I bet you can guess what goes in the middle. 6 pi goes in the middle. We know that just because we know what we're doing, but let's just apply all the rules. I'll take the period, which is 6, and I divide it into 4 equal parts. So what is your interval? 1.5. So I take 3 and I add 1.5, and what do I get? 4.5. But we can't put 4.5 on there. 9 over 2, so 9 pi over 2. Now let's just check and make sure we were right. If we're adding 1.5, that's really adding 3 halves. So 9 halves plus 3 halves is 12 halves, which is 6. So what should the next interval be? 15 pi over 2. And then if we keep going, we would get 18 pi over 2, which is 9 pi. So we're good. Always like to double check by starting with the end and making sure that we're doing our intervals properly. All right, so I have a reflection. I have a cosine graph. So instead of starting up high, I start at minimum, then the mid, then the max, mid, and then. Arrows on the end to show which way you're going. And you're done. All right, any questions about that one? Making a little bit more sense? Okay, good. Just don't let the fractions scare you. You have a calculator. Use your calculator if you need to. All right, last one of this guy. What is the amplitude? 1. Do we have a vertical translation? Yes. I think WebAssign, if that were the vertical translation on WebAssign, you could just put in 3. For me, I either need a +3, a -3, the words up or down, or arrows. Something giving me direction. So I'll just do +3 right here. Okay, what's the period? Pi. Good. What's the phase shift? So it's negative in parentheses, so it has to move to the right. Has to move to the right because it's negative in parentheses. Remember, it moves the opposite way. Horizontal movements go opposite of what you think. When you solve them and you move across the equal sign, you change signs. All right, so what's the phase shift? Pi. All right, so then we sketch it out. I have a translation of up 3, so that's my new midline. Your vertical translation is your midline. What's my max? Y equals 4. What's my min? Y equals 2. Okay. Starting with the phase shift, so I put pi here. Phase shift plus period is the endpoint. So my endpoint is 2 pi. Make my marks. All right, so now I have period divided by 4. Pi over 4. So 1 pi plus pi over 4 is 5 pi over 4. Plus another pi over 4 would be 6 pi over 4 or 3 pi over 2, which is what you should put. So if I go back to 6 pi over 4 and I add another fourth, I get 7 pi over 4. And then just to check and make sure I'm on the right track, I add it again and I get 8 pi over 4, which is 2 pi. Yes?
Not just subtract it from 2 pi.
You sure can. But the only problem with that is this. Let's say that, you know, on the last one, when we were supposed to end at 9, a mistake that I often see is students put the period at the end. And so if you did what you just said, subtracting 1/4, like from 6, that's not going to put you at the right place. The reason I ask you to start with the end in mind is so that as you travel along with your intervals, when you get to that last interval, you can check to make sure you're in the right spot. That wouldn't work if you worked from the end backwards, because you would be assuming that your end spot is correct, and that might not be true. All right, how do we graph this thing? Do we have reflection? No. Cosine starts at the max, mid, min, mid, max. Because you are so good already at sine and cosine, it's going to make secant and cosecant a piece of cake. That's what we're doing tomorrow. All right, before we move on to the last two, are there any questions on how to graph? I don't know how to do the period questions. I don't understand the phase shift, anything like that at all before we move on. Because you really have to understand that before you can do the last two. Okay, so the last two are different because they require that you work backwards. I'm going to give you the characteristics, and you have to write the equations. So I'm going to give you 5 minutes, either solo or with a partner, to work on these last two and see if you can come up with the correct equations. And then we'll work them out together. And then we're going to make up a couple more just to make sure you understand what you're doing. And then I've got one more graph I want to show you because I don't think we've done one in particular. I don't think we've done a sine graph reflected yet. So we'll add one of those at the end. If we finish sooner than 5 minutes, then I'll check it sooner than 5 minutes. And I told you I'm not doing a quiz on Friday. Did I tell you that? Okay, so no quiz on Friday. We're just going to finish out graphing. So tomorrow we'll do secant, cosecant. Friday we'll do tangent, cotangent. Then probably a graphing quiz Tuesday. And I'm also going to extend your WebAssign due date. I'm just not sure what date I'll extend it to yet. Okay? Okay.
It's the formula for period again.
2 pi over b. Well, I mean, it is here, but they use k instead of b. So if you want to change that k to a b, and c over b. Opposite of. Remember, because your horizontal translations have to go across the equal signs, so that changes the sign. Once you get an equation for these that you think is correct, work it backwards. Go back and do like we've been doing, solve for the amplitude, solve for the period, solve for the phase shift or the vertical translation, and see if you've got the right parts. Luke, you already got both?
No, I just got.
You just got the first one. Work on the second one too. There's one thing missing. You have to. Everything else is correct, except for add that in. All except for one thing on both of them are correct. You have to have plus or minus in front of your functions, because if I don't tell you there's a reflection, then the amplitude is what the amplitude is, and it could be an equation with a negative in front, and it could be an equation without the negative in front. So when you are writing equations from characteristics, you always start with y equals plus or minus, unless they say reflection over the x-axis. And in that case, you know it's only negative. Correct. There is no phase shift on this one, but your equation has an argument. You only have the argument if you have a phase shift. You got it? Check with your neighbor if you think you have it. Check and see if you've got the same thing as your neighbor. You are close in 2 ways. The one that needs to be a fraction, and both of them need to have plus or minus in front. Those at that place max. So you did. Both of them are correct with a few exceptions. They have to have plus or minus in front. Yeah. Okay. That is not correct. That will not give you a period of privacy. 2 pi over b. That's the formula for period. 2 pi over b equals pi. Now we're talking. Nice job. All right, let's try the first one together. So when we grade these on an assessment, we grade them by parts, which means that you could get partial credit. So let's say the whole thing was worth 5 points. If you do that, that's going to get you part of a point. Seriously. These are functions, so they need to start out with either y equals, or in the case of sine or cosine, they actually could start out with f of x equals, because they're functions. They both pass the vertical line test. Okay? But either way, has to start out that way. Can't just be starting with my amplitude. All right? The next thing that we look for is that. If that's not in there, you lose that point. That's because if I just tell you an amplitude, and I go back and I do it backwards, if it was negative, it would still have the same amplitude, correct? What does the negative sign really tell you to do? Reflect it. So if it should just be negative, you'll see in the characteristics, reflection over the x-axis. Then you know you only need the negative sign. Okay? The next thing that you're going to do is apply the amplitude. So in the order of the equation that I gave you. So the amplitude is, okay, so there's another part of a point right there. Then we use the trig word, sine. You would be surprised at how many people don't get that credit. They forget to put the trig word in there. Use your trig word. Okay, you can use whatever angle notation you want to. You could use x, you could use t, alpha, gamma, beta, whatever. Okay. Let's talk about whether or not we need parentheses. Do we have a phase shift? Then we do not need parentheses. All right, now let's look at the period. The period is supposed to be 2 pi. So what should the value of b equal? So this is just going to be theta, or your angle notation. Now, I just need to apply a vertical shift down 2. Took care of all those parts. Did anybody get that correct? Yes. Now, if you ever see parentheses like that, that's okay. I don't know why some textbooks denote the angle measurement with parentheses, but that does not make it an argument because it doesn't have any kind of sign in the middle. There's not 2 terms. It's just 1 term. All right, now this next one's a little bit tougher. What do I start with? Y equals. Then what? Plus or minus. Then what? 7 over 2. Nice. Change that decimal to a exact value. Okay. What's the function? Cosine. Do I have a phase shift? Let's go ahead and set it up. My phase shift is positive, so my sign should be negative. I also have a vertical shift. That's an easy point to get. Plus 7 at the end. That would get you partial credit right there. So now let's figure out how to get the other pieces. We have to work backwards. So I'm going to extend the screen a little bit so you can see how we would do this. What is the formula for finding the period? So if I set it up like this, period equals 2 pi over b, and I use the information they gave me, what is the period? Pi over 2. So I'm going to say pi over 2 equals 2 pi over b. Now what? Cross multiply. So b pi equals 4 pi.
Divide by 5.
I'm solving for b, correct? I can get rid of the pi's because I got one on either side, and so b equals 4. So I go back up and I make this 4 theta.
Say 4x.
You can say 4x, whatever notation you want to use. Okay, now let's do the same thing for the phase shift. We've already applied the negative sign. So phase shift equals C over B. Well, they told me the phase shift is, I forgot, pi over 4. So pi over 4 equals C, that's what I'm trying to find, over 4. 4 pi equals 4C. What happens? I divide by 4, and pi equals C. All right, now your last step should be go back and work it backwards like we know how to do. So we have an amplitude of 3.5, check. We've got the cosine function, check. My period is supposed to be pi over 2, so if I work it backwards, it's 2 pi over 4, and what is that? That's pi over 2, good. My phase shift should be positive, and I have a negative sign, and it's C over B, so pi over 4, that's good, and a vertical translation of 7. What do you think? Okay, good. Here's your next one. This is a sine function. There is a reflection. We're going to graph this one too. Reflection over the x-axis. Let's do an amplitude of 3. I want the period to be 4 pi over 3. I want the phase shift to be negative pi over 6. And I want the vertical shift to be plus 2. So try getting the equation and then graph it, and we'll do it together. Try to throw some fractions in there so you have to think about it a little bit. You see that. Plus, we've not done together a graph that's been a reflected sine graph, and I just want to make sure that we do one of those together. If you can do these, you really have a good handle on the graphing. There's usually a bonus on the test that says, write an equation given these characteristics for both sine and cosine. The same equation for sine and cosine. Do you remember what the difference is between the sine graph and the cosine graph? You're right. That's not an incorrect statement, but in terms of phase shifts, pi over 2. So one of the graphs could be shifted pi over 2, depending on which way you're looking at it. And you can always write another equation that's the same one. Kind of like the one we did for sine, where we just shifted it 2 pi, and it ended up looking like the same graph as a sine graph. That's what I'm talking about. That's always a bonus. Fractions tough on this one? It's okay to use your calculator. Superior's got it already? You don't know? Maybe? Go back through and look at backwards. Look at backwards and see if you get those characteristics. Well, I think you have it. Josh, what about you? Maybe? Do you have something? Okay, good. So what should we start out with? Y equals. Let's start there. Then what? Just negative this time. Why? I said it was a reflection. So if you had put the plus or minus, then you're already on the wrong mark. It's just negative this time. All right, amplitude. Trig function. Okay. Do I have a phase shift? So I need to open up the argument, right? If the phase shift is negative, that's a plus. And then I always go to the vertical shift. That's easy. We can get that taken care of quickly. Everybody get that correct? That's good. That's a good starting place. That's at least partial credit. So now let's work on the hard stuff. So period 4 pi over 3 equals 2 pi over b. Now we cross multiply. So 4 pi b equals 6 pi. What happens to the pi? They cancel, so I've got 4b equals 6. B would either be 6/4 or 3/2. So 3/2, we'll call it x this time. That's my angle notation this time is an x. I can change that. Change it to theta, make it beta, gamma, whatever you want to do. Okay, so how many of you got 3/2? Excellent. See, y'all, that's the hardest thing is to be able to work backwards from these formulas. So now let's do phase shift. All right, this was for the period. Now let's do phase shift. All right, phase shift is, we're going to call it negative pi over 6. So pi over 6 is equal to C over D, which is 3/2. So 3/2 pi equals 6c. I'm trying to solve for c. So I divide each side by 6. So 3 pi over 2 divided by 6 equals c. This would be a keep it, change it, flip it. So what's my fraction? So it ends up being 3 pi over 12. Look, keep it, change it, flip it. This is 6/1. Did you not just divide by 6? So to flip it, it becomes 1/6. So this would be 3/12 or pi over 4. What do you think? Anybody get all of that on your own? That is awesome. All right, now comes the hard part. Yes, ma'am.
If you put 1/4 pi, that is
Perfectly fine. Same thing. I'm actually glad you recognize that as 1/4 pi. That's good. All right, so now let's graph this thing. This one's a little bit tougher to graph. So the phase shift is negative pi over 6. So we're going to start that down here. I have a vertical shift up 2, so this would be y equals 2. And I have an amplitude of 3, so what's my max? Y equals 5. And what's my min? Y equals -1. Okay. So phase shift, be careful on this. Phase shift, negative pi over 6, plus period, 4 pi over 3. equals ending point. Leave the pi out of your calculator and just do the fractions. Negative 1/6, put that in parentheses if you need to, or put the fraction in and hit enter, plus parentheses 4 divided by 3. And then hit math frac. What do you get? 7 pi over 6. Okay, now I have a question for you. What is the distance between negative 1/6 and positive 7/6? 8/6. What does 8/6 reduce to? 4/3. Follow me? The distance on the horizontal grid from a negative 1/6 to a positive 7/6. Negative 1/6 to 0, right? And then all the way out to 7/6. That's 8/6. 8/6 reduces to 4/3. Okay, now this comes the hard part. I need to take the period, 4 pi over 3, and divide it by what? 4. And then hit math fraction and tell me what you get. Say it again. 1/3. 1/3 plus 1/3 plus 1/3 plus 1/3 is 4/3. That was easy. Negative 1/6. Your calculator. Plus 1/3. Math fraction. Say it again. Pi over 3. Is that what you guys are getting? I don't see looks of confirmation. Okay, well let's do it together so that everybody can get the same thing. In your calculator, put in negative 1 divided by 6 and hit enter. Put in plus. We said our interval was 1/3, so put parentheses in. 1 divided by 3. Now hit the other parentheses to close it out and hit enter. Now hit math frac.
Yeah, I got 1/6.
Okay, so what's the answer? 1/6 or 1/3? It's 1/6.
Also, okay.
Do we need to do the fraction problem out?
No, you did 1/3. Somebody
I
said-
know that's what somebody said 1/3. That's why I'm like, you guys need to do that again. It's not 1/3. So now add 1/6 plus 1/3. One half. So pi over 2. This is like painful here for you guys. Add 1/2 plus 1/3. Say it again. 5 pi over 6. I'm worried about this right here. What is 5 pi over 6 plus 1/3? 7 pi over 6. That's what I need to double check every time. If I've done phase shift plus period equals ending point correctly, when I add my last interval, I'll end up at that last point. Okay, now, this is the first time we've done a sign that's been reflected. Sign always starts at the same place, which is where? The midline. It will still start at the midline. But what do we do since it's been reflected? We're going to go to the minimum instead of starting the next point at the maximum. So it goes down, and up, then max, then mid. Remember, always starting and stopping at the same point. Yeah. Do you guys remember doing an activity when you were maybe in elementary school where you made a foldable? And the first flap was 1 unit. And then underneath it, you cut that flap into 2 units and made that a half and a half. Underneath that, you did thirds, 1/3 plus 1/3 plus 1/3. Underneath that, you should have done fourths. Then usually you do 6s and then 12s. That's what most people do because those are just really common fractions. You know what? It might not be a bad idea for you to do that. Because fractions are what's holding you back from being successful. You guys can do the trig. Like, once we get this grid done, you know exactly what to do. It's getting the grid finished that you're struggling with. So the fractions, use your calculator if fractions is a real struggle for you, okay? Tomorrow, secant and cosecant with your groups. And yarn. More yarn all over the place. And yarn. And yarn.